Hello everyone, I am Lakshmi, pursuing third year engineering graduation from VIGNAN Institute of Engineering for Women. I am taking an machine learning with Python course from Skyfi Labs, and as a part of it I am assigned to do an project, and my project is about diabetes prediction. This diabetes prediction project is used to predict the possibility of the diabetes of a patient based on the data analysis. Now let's start our project in detail. Firstly, import all the required packages. Initially import NumPy package as NP. This NumPy package is used to handle multidimensional arrays. Next, import Pandas package as PD, which makes easy to use data structures and data analysis tools for Python. Next, import matplotlib as MPL, which used to draw graphs. Next, import funcAnimation from matplotlib.animation, which helps to generate animations and to visualize the data. Next, import sklearn package, and this is one of the most important package in machine learning. It helps to provide many modules and data sets in the machine learning, and also helps to pre-processing of data, model evaluation, and etc. Now import our data set called load_diabetes, which we consider as the data set for our project. Next, import mean square error from sklearn.metrics, which helps to compute the mean square error between the predicted values and the true values. Next, import train test split from sklearn.module selection, which helps to split the training and testing data. Next, import min-max scaler from sklearn.preprocessing, which helps for the normalization of the data. And finally, import HTML from ipython.display, which helps to view the results on the screen. As we all know that the first step in machine learning is data pre-processing, and for that firstly we should load our data set in a diabetes variable as shown. Then we can view the description of the data by using DESCR keyword. This keyword prints the description of any data set, and we can view the description of our diabetes data set as shown. And our diabetes data set contains 442 instances and 10 columns of attribute, namely age, sex, body mass index, average blood pressure, and so on. Here S1 to S6 are the different blood measurements which are collected from 442 patients. And we have also another column called target, which is a quantitative measure of disease progression. And we can view the description of our diabetes data set as shown. Then our next step is to put the data into Pandas data frame into a variable called features, and we can print the data frame by typing the features. Now we can view the data in the columns of the data frame. We can perform simple queries on the data frame by printing the age column as shown. This will display the age column in the data frame. And the next step is to store the target into another data frame called target, and we can print the target column by typing target. We can view the target column as shown. Then we can perform simple queries on the target column by printing the maximum and minimum possibility of prediction of diabetes. This gives us the maximum value and this gives us the minimum value. Now concat features and target into a single data frame, and for that we had used concat function, which is provided by the Pandas data frame. Here axis is equals to 1 used to concatenate the two data frames in side-by-side format. and we can view that the target column is added at the end of our data frame. And then we had used describe function. Here describe function is used to generate the summary of the data set. It is used to describe the statistical description of the data set such as count, mean, standard deviation, minimum and maximum values, etc. And here we had used round of decimal is equals to 2 in order to round the digits into 2-digit numbers as shown. Now let us calculate correlation between every column of the data. Before calculating the correlation, let us discuss what is correlation. The correlation describes how the values in one column are dependent on the values in another column. So finally, we will choose the attribute with highest absolute correlation as the independent variable to perform linear regression. And now, the pandas data frame provides core function which takes the parameter as what correlation to be used. And then after calculating the correlation between every column, store it in core variable. Then take absolute values of the correlation. Extract absolute correlation between each attribute with the target attribute by using list from correlation data frame and store in course variable. Then make a list of pairs of core and features by using zip function and list function in the Python and store it in L variable. Then sort the list of pairs in descending order. And here we had used lambda function which helps us to extract the key for sorting. Then unzip the pairs of two lists, course and with its label by using zip function. Now plot the correlation with respect to the target variable as a bar graph. Generate a list of emphasis in a range that is equal to the length of number of attributes. This list acts as an index for the items will be generated as a parameter to the functions for plotting the graph. Now set the size of the figure to prevent the labels from squeezing together. Next, by using plot.bar, we can generate the graph. Next, label x and y axis as shown. This is an optional phase. By using xsticks provides labels bar by passing index labels as an argument, and by using plot.show we can generate the graph. Finally, the graph has generated as shown. Here we can observe that the body mass index BMI has the highest absolute correlation value, then S5 attribute, and then BP, and so on. This says that if a patient data of different attributes with the highest BPI value, there is a chance of getting the diabetes to the patient. Then S5 attribute, BP, and so on. And finally, we will select BMI as the independent variable for our linear regression model. And our next step is to normalize the data. We will normalize the data using min-max scaler which is provided by the sklearn package. Before that, select X and Y columns, where X column contains the BMI values and Y column contains the target values. The goal of normalization of the data is to change values such that after transformation all the values lie at a common scale ranges from 0 to 1. And hence the data becomes easier to interpret. Now let us visualize the data before normalization and after normalization. And here we can see before normalization of the data, the Y columns are at some arbitrary range. Now let us perform the normalization. Here min-max scalar function takes values in any arbitrary range and gives the values in 0 to 1 range. And here fit transform function computes the minimum and maximum, transforms the values and return the normalized values. And now we are assigning x scalar variable to the min-max scalar. Then we are assigned this x scalar to the fit transform function by reshaping the x values, and we are stored in the x variable. And after this scaling process, an extra dimension will be added to the values of x column. So in order to remove it, we will perform slicing operation here and follow the same steps for the y columns. And now we can view that after normalization, the values of y column are only in the arbitrary range of 0 to 1. This is called the normalization of the data, which helps the data to become easier to interpret. The next step in the machine learning is to define the error function. Here our objective is to minimize the error function. Now we will compute the error between the true values and the predicted values. Here the true values are the values from the data set and the predicted values are the values that we will compute from the current weights. Here the weights are M and C. After computing the difference between the true value and the predicted values, compute the sum of squares of differences and divide the quantity by the number of examples in the data set to obtain the mean square error. Here we will use mean square error because it makes easier to calculate the gradients. And now the fourth step in machine learning is to train the model. After splitting the data into testing and training data sets, we have to train the data. And for that, we will use gradient descent algorithm. The gradient descent algorithm is an optimization algorithm in machine learning to minimize a function. It minimizes the cost function. The gradient descent algorithm is updated with three functions: update function, error function, and gradient descent function. And let us view the functions. The update function. The purpose of update function is to update weights which closer to the final values. It calculates gradient at current position. It updates M and C values. It takes the parameters as current values of M and C, attribute value X, target value T, learning rate, and it returns the updated values of M and C. And let us come to the error function. The purpose of error function is to calculate the cost function value at the current position. It takes the parameters as M and C, attribute value X, and the target value T. It returns the error value. And next, let us know about gradient descent function. The purpose of gradient descent function is to apply gradient descent on cost function. It obtains best fit values for M and C, and it takes the parameters as initial values of M and C, attribute value, target value, and the learning rate, number of iteration, and error threshold. It computes the values of M and C, and it finally returns the values of M and C and lists all the M and C values, error values. Now set all the values and call the gradient descent function. Initialize M value as 0.9, C as 0, learning rate, iteration, and error threshold as follows and call the gradient descent with correct order of parameters and execute it. Now, as the number of iteration increases, changes in the line are less noticeable. In order to reduce processing time for the animation, it is advisable to choose small value, and hence we are using slicing operation on MC values and store this slicing operation values in MC values and variable. Now we are animating the linear regression model, and for that we are using subplots which returns two objects called figure and axis, and then obtain line object from PLT which calls x and y coordinates as empty sets, and we are setting animated is equals to true in order to generate the animation. Generating animation requires two functions called init and update frame, and let us view these functions. The purpose of init function is to call back function initialize graph and to draw the training data such that it is in the background and sets the limit of x and y axis. It takes no parameters and returns the line object. And coming to the updated frame function, the purpose of this function is to update each frame, and using MC values we compute coordinates for the endpoints of the regression line. It takes the parameter as the frame number and returns the line object. And now we are using funcAnimation function. It takes the parameter as figure, updated frame, frames, init function, and blit is equals to true. This blit is equals to true is used to improve the performance. And finally we are using the HTML function in order to generate the animation. In my system there is a video program and hence the animation is not appeared, but we can view the x-train and y-train coordinates axis in the green color dots. And now let's visualize the learning process. It includes plot the regression line and plotting the change in regression line through the training process. The plotting of regression line against the training data set is to visualize what the line looks like for the training data set. Plotting the change in regression line through the training process. This graph helps to visualize how MNC values are updated after each step. Now let us plot the regression line. Plot the regression line upon the training data set. Use the scatter function which takes the parameter as x-train and y-train and use blue color in order to represent it. Now plot the regression line by using plot function which takes the parameter as x-train and we give the slope of the line. Represent the line with red color, and now we can view the graph as follows. Now we can observe the graph that the training data is not on a straight line. It has a slight curve. The line that the model has predicted is a good approximation to the current value, as the line lies roughly in the center of most dense part of the training data. This means that the line gives good prediction of the diabetes for the most of the input values. And the final step in the machine learning is prediction. In order to predict the values, we have 4 steps. And the first step is to compute the predicted value of each x value using line equation m and c values from gradient descent function. And the second step is to reshape predicted x test, y test arrays from row to column. And the third step is to scale predicted X-test, Y-test arrays and store them as predicted scale, X-test scale, Y-test scale using inverse transform function. And the fourth step is that as scaling adds an extra dimension to each of the arrays, and hence in order to remove it we will perform slicing operation. And now calculate the predictions on the test data set as a vectorized operation and stored in the predicted variable. Now calculate the mean square error on the testing set by using mean square error function which is provided by the sklearn package, which takes the parameters as Y-test and predicted. And after executing we can view the mean square error value. And after that put X-test, Y-test and predicted values in a single data frame in order to view how predicted values are closer to the target value and view the data frame. And finally from the output we can view that the predicted values are nearly close to the target values as shown. Now plot the predicted values against the target values. Use the scatter function and plot function. Use blue color and red color in order to represent the graph, and now we can visualize the graph as shown. Here predicted values are represented by red colored line and the target values are represented with blue color points. And now we doesn't want the predictions in the form of normalization, and hence we will reshape the values and we retrieve the original format of the values, and hence we will reshape the predicted X-test, Y-test values as before as shown. And now we can view the values before the normalization format. And finally we had done the prediction of the diabetes of a patient successfully. Thank you.